Class 1, Chapter number 2, Periodic Classification of Elements. See here, last time we have seen this modern periodic table, and now we are going to study modern periodic table and electronic configuration of elements. In a period, neighboring elements differ slightly in their properties, while distant elements differ widely in the property. Example, you will take it as sodium and chlorine belong to the third period, whereas sodium is the metal and chlorine is the non-metal. Second example, you can take it as iron and arsenic. Both belong to the fourth period, whereas iron is the metal and arsenic is the metalloid. Similarly, in period, any two elements will show slightly different properties. Elements in the same group show similarity and gradation in their properties. Here, if you consider the second group, consider beryllium and magnesium. Both show the same chemical properties and they are called as alkali earth metals. Here you can take second example as the halogen families, where chlorine and iodine both show the same chemical properties and they are placed in the 17th group. In the same way, any two elements from the same group will show the same properties. These characteristics of groups and periods in the modern periodic table are because of the electronic configuration of the elements, as well as these electronic configuration of elements decide the group and the period in which it is to be placed. Here you can see the modern periodic table. Elements are arranged in the increasing order of the atomic number Z. There are total 18 vertical columns called as groups. The chemical properties of the elements in the same group show similarity and gradation. Whereas the horizontal rows are called periods, there are total 7 periods. The property of element changes slowly from one end to the other in a period. Group and electronic configuration. The number of valence electrons in the same group is the same. For example, group 1 is a family of alkali metal have one electron in its outermost shell. You can see here the example. This is group 1, they have one electron in the outermost shell. Second example, you can take it as the alkali earth metals, they have two electrons in the outermost shell. Third example, you can take it as a 17 group, which is a halogen family. They have 7 electrons in the outermost shell. While going from top to bottom within any group, one electronic shell gets added at a time. However, as we go down a group, the number of shell goes on increasing. Obviously, you can see here, as you go from top to down, the number of shell goes on increasing. Here it is 1 shell, 2 shells, 3 shells, 4 shells, and so on. The number of shell gets added at a time, one by one, as you go down the group. The electronic configuration of the outermost shell is the characteristic of a particular group. Yes, you can see here. This is the atom, whereas this is the outermost shell, and the outermost shell is also called as the valence shell. Periods and electronic configuration. The number of valence electron in the same period is different. For example, second period, sodium has one valence electron, whereas magnesium has two valence electrons. Here you can see sodium has one valence electron and magnesium has two valence electrons, while they are belonging to the same period, that is 3. Next example, you can take it as potassium and calcium belonging to the fourth period, whereas potassium has one valence electron and calcium has the two valence electron in its outermost shell. The elements with the same number of shell occupied by electrons belong to the same period. However, the number of shell is the same. Here you can see, if you take the third period, they have 3 shells. the shells remains the same. While going from left to right within the period, the atomic number increases by 1 at a time and the number of valence electron also increases by 1 at a time. Here you can see as you go from left to right, the atomic number Z increases by 1. Hydrogen is 1, helium 2, lithium 3 and so on. As well as the number of electrons also increases. Here you can see lithium it is 1, then beryllium 2, boron 3, carbon 4 and so on. 1 electrons get added. See students, here you have shown the electronic configuration where it has been distributed in such a way that first shell has a capacity to hold 2 electrons, second shell has a capacity to hold 8 electrons, third shell also has a capacity to hold the 8 electrons. If 2 electrons are filled here, then the next third electron will go in the second shell. If here 8 electrons are filled, then the ninth electron will go in the next shell. And if here the 8 electrons are filled in the third shell, then the ninth electron will go in the next shell and so on. Example, here we will take it as carbon. Atomic number Z is 6. So electronic configuration is 2, 4. Okay. Next, if you will take chlorine, its atomic number Z is 17 and electronic configuration is 2, 8, 7. For this, from hydrogen till calcium, the electronic configuration you have to keep in mind. Any element we will be asking in exam and you have to write down the electronic configuration for that. Now you consider the second period, lithium, beryllium, boron and so on. They consist of 2 shells, that is K and L shell. The next third period, sodium, magnesium, aluminium and so on, they contains 3 shells, that is K, L and M shell. Thus, the number of elements in the first 3 period is determined by the electron capacity of the shell and the law of electron octet. Here you have seen the K shell has a capacity to hold 2 electrons, L shell 8, M and so on. Here you can see the clear image. The first shell is the K shell, second shell is the L shell, third shell is the M shell and the fourth shell is the N shell and the so on. And in the next year they have given the electronic configuration. First shell for the hydrogen, 1 electron in its outermost shell. Second shell, example is carbon, 4 electron in its outermost shell. This is the outermost shell where its 4 electrons are present. Third shell, it is the phosphorus where the outermost shell it consists of 5 electrons, and you find it out for nitrogen, oxygen and sulfur how many electrons are present in its outermost shell and find out its valence. Here the concept of valency will be cleared. Earlier standard you have studied valency of an element is determined by the number of electrons present in the outermost shell of its atom. Here you have given the elements from hydrogen till calcium, its symbol, atomic number, number of electron and distribution of electrons in different shells, that is K, L, M and N shell, as well as the valency. If you consider the element sodium, it has atomic number, level and the electronic configuration is 2, 8, 1. So the valency of sodium is 1. Why? Because it is easy to give off 1 electron and become stable as Na plus ion. Okay, rather than accepting the 7 electrons. Next example, you can consider it for the chlorine. The atomic number is 17. So the electronic configuration is 2, 8, 7. Where here I have said you need 8 electron to complete its octet. So it is easier for chlorine to accept 1 electrons and became chlorine minus ion. That is, the valency will be 1 because it is accepting one electron and getting stable, completing its octet state, and it will become chlorine ion. Okay, similarly you can find out the valency for the different elements which is being given here.